So we're just doing kind of a really awful 7 resistor circuit that I just came up with just to torture people. And here's the circuit. And well, it kind of went parallel series, parallel series, parallel series. And so we ended up with the total. Okay, let's do it like this. The total current was 61.3 milliamps. Well, now I'm going to actually get another sheet of paper going. So I'm going to have, I want to talk about R1, V1, I1, R2, V2, I2, R3, V3, I3. I might not get through this whole circuit, so I'm just going to just kind of stop there and sort of fill in as I go along. Now, I call this R1. Now, because of Kirchhoff's law, I know something, which is that every single little bit of current that leaves this battery has to enter the battery, and the only way that it can enter the battery is through R1. So I know I1 is going to be I total, so that's going to be 61.3 milliamps. Now I know V equals IR, so R1 is 100 ohms, so V equals IR. That is going to mean that 100 times my previous answer, 100 times answer is going to be 6.12 volts. 13 volts. 6.13 volts. Now, I probably could have put this up on one page, but here it is. Now, I know that this is 0 volts, and I now know that this right here, that point, is 6.13 volts. Now I know that the total drop is, well, I'm way up here where you can't see. I'm sorry. I know that this is 6.13 volts. So I know that the total drop across R2, is 12 minus that answer, is going to be 5.87. So my voltage drop across R2 is 5.87 volts, and that resistance all by itself is 200 ohms. And so V equals IR, if I take 5.87 divided by 200, I'm going to get 29.4 milliamps. 29.4 milliamps. Well, now I had 61.3 milliamps, and this, I understand this is a crazy circuit. You don't have to tell me. I'm not going to say it again. I'm going to stop apologizing, and I'm just going to go. 61.3 milliamps is going in here. 29.4 milliamps is going this way. So that means that for this circuit right there, going through R3, it's got to be 61.3 minus 29.4. So I've got 61.3 minus 29.4. I've got 31.9 milliamps. And that resistance is 150 ohms. And so now I've got V equals IR, so I take 0.0319 times 150, and I get 4.79 volts. Okay, now I said that this entire drop from this point to this point was 5.87 volts. So from here to here has got to be a total drop of 5.87 volts. and this one just dropped 4.79 of it. So now I know R4 is 50 ohms, V4, I4, so I'm going to say 5.87 minus my answer is going to be 1.1. Let's see. Let's just do it this way. 5.87 minus 4.79. It's going to be 1.08 volts. So I know V4 is going to have a drop of 1.08 volts. V equals IR, so I is V divided by R, so I take that divided by 50, and I get 21.6 milliamps. So 21.6 milliamps is going through R4. Well, 31.9 milliamps is going through R3. So I know now we're on to R5. I might actually get through this if I hustle. So I know R5 is going to be 40 ohms, and I'm going to say that my I5 is going to be 31.9 minus 21.6 is going to be 10.3 milliamps, and then V equals IR, so I take 0.0103 times 40, and I get 0.412 volts. Now, I know that the total drop across R4 was back here 1.08 volts. And so now I know that this is going to be 1.08 volts, and that is 0.412 volts. So I know R6 and R7, now I'm down to it. Now I'm getting there. Now I can see the solution. Okay, so now I'm going to see that this voltage is going to be 1.08 divided by 0.412, so I'm going to get 0.067, and it's going to be the same. Now I'm down to my last, so I know it's the same, and so I'm going to get V divided by R, divide that by 100, and I'm going to get 6.7 milliamps, and I'm going to get half of that, 3.3 milliamps. So if I add those together, I should get 10 milliamps. Well, I get 10 milliamps. Now we've got all kinds of rounding error all the way through the problem. So, but you can sort of look, and this plus this is approximately that. This plus these two added together make that, and it all works out. And there's sort of the worst awful circuit, and then we're going to talk about some things that aren't circuits in a couple of videos.